Have you ever wished digital worlds felt as real as the one around you? Or that, a virtual experience could truly put you in another place, making you maybe forget where you physically are?
Yeah, that feeling of genuine presence, of actually being transported. That's really the core of what we call immersive experiences.
That genuine presence you're talking about, it's kind of the holy grail, isn't it? And our mission today really is to uncover how we're building that bridge, making the digital truly immersive.
Uh-huh.
We're going to explore the technologies that are, well, blurring those lines between virtual and reality.
And for this deep dive, we've looked at quite a bit of material. We pulled insights from detailed presentations, some really interesting audio discussions too, and even a look at the tools used to analyze the data behind all these trends.
So you, the listener, are going to get a pretty comprehensive understanding, hopefully, of immersive experiences, the metaverse,
Hmm.
spatial
It's
computing.
how it all connects. Yeah, it's a lot, but it fits together.
So, okay, let's start with the basics. When we talk about immersive experiences, what are we really saying?
We're focusing on technology that creates that feeling, that sense of genuinely being present in a digital environment.
Right. It's not just looking at a screen.
Exactly. It's feeling like you're inside it.
Okay. And there are different ways to get there, right? Different flavors of immersion.
Definitely. And it's important to get these straight. First, you've got virtual reality, VR. That's when you put on a headset like the Oculus or something, and the real world just disappears. You're in a completely virtual simulated space. Total immersion.
Okay, total replacement. Then there's augmented reality, AR. That sounds different.
It is. Think of AR as more of a digital overlay. It doesn't block out the real world. Instead, it adds things to it. Virtual objects layered onto what you already see around you.
Like putting virtual furniture in your real room before you buy it.
Exactly like that. It enhances your current reality, doesn't replace it.
Got it. And then there are these bigger concepts looming over it all, the metaverse. That word gets thrown around a lot.
It does. The metaverse, the vision for it anyway, is this persistent, interconnected network of 3D virtual worlds. Like a future internet, but in 3D.
A place where you can socialize, work, play, learn, all within these connected virtual spaces.
That's the idea, a kind of parallel digital universe.
Okay. And the last piece of jargon, spatial computing. What's that about?
Spatial computing is kind of the underlying intelligence. It's the tech that processes spatial data where things are in 3D space.
So it's what lets the digital stuff interact meaningfully with the physical world, not just float there.
Precisely. It understands the space around you. That's key.
It's amazing how these ideas aren't entirely new, though. Our sources pointed out that people have been dreaming about this stuff for a while.
Oh, yeah. Way longer than you might think. The journey toward immersive experiences started, well, quite a long time ago.
Like back in 1962, with something called the Sensorama.
Believe it or not, yes. Morton Heilig created this thing. It wasn't just a movie viewer. It was a multi-sensory theater device, really ahead of its time.
Multisensory how?
Well, it had stereoscopic visuals, so 3D images, stereo surround sound, but then it also had odor emitters.
Wait, smells?
Yeah, releasing scents timed to what was happening on screen, and even a vibrating seat for tactile feedback, like feeling bumps in the road.
Wow, so Heilig was really trying to immerse all the senses.
Absolutely, beyond just sight and sound.
But it didn't take off. Obviously, we don't all have Sensораmas at home. Why not? What's the lesson there?
Well, the big takeaway is that innovation isn't enough on its own. The ecosystem has to be ready.
Meaning?
Meaning, Heilig struggled with funding for more research. The tech itself was super complex and expensive for the time. Plus, there wasn't much content, just pre-recorded films, no interaction.
And it wasn't exactly portable, I'm guessing?
Not at all. Heavy, bulky. So, brilliant idea, but the timing and the practicalities just weren't there. A blueprint, but not a product for its era.
Okay, fast forward a few decades to the 90s. Sega VR. I remember hearing about that.
Right. Revealed in 91, planned for 93 release. It looks surprisingly like modern VR headsets, actually.
What could it do?
It had head tracking using an accelerometer, so the view changed when you moved your head. It had little LCD screens for each eye for the 3D effect, stereo audio. Sega was really pushing to bring VR into living rooms with their Genesis console.
But again, it never actually came out, did it?
Nope, canceled before launch.
What killed it this time? Similar problems.
Some similar, some new. The technology was still, frankly, immature. People reported dizziness, visual lag, motion sickness was a big issue.
And the console probably couldn't keep up.
Exactly. The Sega Genesis just didn't have the horsepower for smooth 3D worlds. There was also a big gap between what they advertised and what it could actually do.
And safety concerns, too.
Major ones.
Yeah.
Worries about eye strain, disorientation. And since it completely blocked your view, people bumping into things was a real risk. So, yeah, another ambitious attempt that the tech just wasn't ready for.
So, if these early tries stumbled, what finally kicked things into gear? How did we get to where we are now?
Well, you could argue a major turning point was Pokémon GO in 2016.
Yeah. That was everywhere. It really brought augmented reality to the masses, didn't it?
Absolutely mainstream. It
Yeah.
cleverly combined AR with your phone's GPS and sensors. And a key tech it used was SLAM simultaneous localization and mapping.
SLAM. What's that do?
It basically lets the software understand the environment and pin the virtual Pokemon to a specific spot in the real world. So they didn't just like float around randomly when you moved your phone.
Made it feel more real.
Much more. And it all synced through the cloud in real time, which was pretty impressive back then.
The social impact was crazy. People were actually going outside, meeting up.
Yeah, encouraging outdoor activity, social interaction. It connected players to real places, landmarks, public art. There were even official collaborations, like with the Taiwan Tourism Bureau, using it to highlight spots.
But it wasn't all smooth sailing. There were definitely downsides.
Oh, for sure. Unforeseen challenges popped up. Safety was a big one. People walking into traffic, trespassing.
Right, the distracted walking phenomena.
Exactly. And sadly, even some serious incidents like gun-related issues in the U.S. linked to players going places they shouldn't, plus nuisance things like crowds and noise.
Still, you can't deny its impact. It made AR feel normal, accessible.
Undeniably. It massively accelerated public acceptance and showed immersive tech could be fun and engaging for almost anyone with a smartphone.
Okay, let's leap forward again. 2020s, the Apple Vision Pro. This felt like a different beast entirely. Apple called it spatial computing.
Yeah, they definitely positioned it as more than just VR or AR. They were aiming to fundamentally change personal computing.
And the tech inside sounded pretty wild.
It really was cutting edge. Eye tracking, so you could select things just by looking at them, no head turning needed. Hand gestures for control, no physical controllers required.
It understood your room.
Deeply. Its spatial awareness created 3D maps of your surroundings, letting apps kind of float in space or stick to walls. Very futuristic.
The displays were supposed to be incredible too, right? Like no pixels visible.
Ultra-high resolution, over 4K per eye. They were aiming for that no graininess feeling, like an IMAX screen right in front of your eyes, plus spatial audio that adapted as you moved your head.
Sounds computationally intensive.
Extremely. It had a dual chip system, the M2 chip, like in their Macs for general stuff, and a dedicated R1 chip, just for processing all the sensor data cameras, microphones, motion sensors.
Why have a separate chip?
To reduce latency. That lag between moving your head and the image updating is a major cause of motion sickness. The R1 was designed to minimize that delay.
And that eyesight feature, where people outside could see your eyes.
Yeah, that was an interesting attempt to make it feel less isolating. Let people see your expressions through the headset.
So with all that tech, what was the grand vision? What was Apple really trying to do?
They were swinging for the fences, trying to redefine computer interaction, move beyond keyboards and mice into truly spatial interfaces where digital content merges with your physical space.
So applications like super realistic remote meeting.
Exactly. High realism collaboration, social interaction, and huge potential in education. Imagine medical students doing simulated surgeries or virtual internships offering hands-on experience.
But, and this is the big but from our sources, despite all this, its future looks uncertain.
That's the bombshell, really. Our sources are indicating the Apple Vision Pro has been discontinued.
Discontinued already. Wow.
Yeah, and that there won't be a next-generation Vision Pro. They even mentioned piles of secondhand inventory cropping up.
That's staggering. For such a hyped, advanced piece of tech, why? What went wrong? Especially when others like Google, Meta, Asus are still in the XR game.
Well, a few major things, I think. First, the price. Over 3,000 US XOIs that immediately limited it to professionals, developers, or very wealthy early adopters.
Not exactly mass market.
Not even close. Then there's the comfort issue. Reports of neck strain, eye fatigue, dryness. Wearing it for long periods wasn't ideal.
But maybe the biggest killer was content.
That's what I suspect is the core issue, the content conundrum. Amazing hardware needs amazing software and experiences to justify its existence, especially at that price.
And creating that high-end content, like those surgery simulations, is hard and expensive.
Incredibly so. Apple's curated, high-polish approach contrasts with, say, platforms like Roblox or VR chat in Web3, which thrive on user-generated content. If there isn't a constant stream of compelling reasons to put the headset on,
It gathers dust, even if it costs $3,000.
exactly. Without that killer app ecosystem and facing those price and comfort hurdles, even Apple's might couldn't guarantee success. It's a tough market.
So stepping back a bit, what's the fundamental tech framework that makes any of this possible? From Sensorama's Dream to the Vision Pro's reality check. Let's start with the hardware.
Right. At the most basic level, you need the gateways. That's your headsets, VR goggles, AR glasses, and things like hand trackers or controllers to interact. The physical interface.
Then you need the brains, the software.
Absolutely. Several key pieces here. You need 3D rendering engines. Think Unity, Unreal Engine. These are the toolkits developers use to actually build the virtual worlds, the characters, the objects.
The digital construction kits.
Pretty much. Then you need spatial perception and SLAM.
Yeah.
We mentioned SLAM with Pokémon GO. This is crucial for AR and MR, making sure virtual objects stay put in the real world and the system knows exactly where you are in that world.
Keeps things grounded.
Literally. And finally, interactive logic systems. This is the software that translates what you do, your hand movements, your voice commands, maybe even your eye movements, into actions within the virtual space. Makes it interactive, not just passive viewing.
Makes sense. Hardware gateways, software brains. But how does the information get back and forth, especially for complex stuff or multiple users? That sounds like a network challenge.
Huge network challenge, and advances here are critical.
Like 5G.
5G is a big one. You need high bandwidth and, crucially, low latency, minimal delay to stream high-res content like 4K or 8K smoothly.
And low latency stops that motion sickness problem too, right?
It helps massively. 5G also enables these experiences outdoors, untethered from Wi-Fi.
What about cloud computing?
Also a game changer. Instead of the headset doing all the heavy lifting, which makes it hot and drains the battery, you can offload complex processing to powerful servers in the cloud.
So the headset can be lighter and maybe cheaper?
Potentially, yeah. And you get higher quality experiences because the cloud servers can handle much more demanding graphics and physics calculations.
And for multiplayer stuff like the Metaverse.
That's where real-time data synchronization comes in. It's absolutely essential. Everyone in a shared virtual space needs to see the same thing happening at the same time. Your actions need to instantly reflect for others.
So everyone's experience stays consistent.
Right. Without it, collaborative or social VR just falls apart.
Okay, we mentioned AR earlier, but sometimes you hear the term mixed reality, MR. Are they the same thing? Our sources seem to suggest there's a key difference.
There is, and it's an important distinction, though the terms get used interchangeably sometimes. While AR just overlays virtual stuff onto the real world.
Like a digital sticker on reality.
Kind of, yeah. Mixed reality, MR, implies a much deeper integration. Virtual objects don't just sit on top of the real world. They actually interact with it.
Okay, interact how? What's the aha moment there?
It comes down to physics, basically. True MR takes things like light physics into account.
Light physics.
Yeah. So a virtual object in an MR scene should cast a realistic shadow on your real floor. It should reflect light from your actual lamps. If you walk past a real window, maybe you see the virtual object's reflection in it.
Whoa, okay, that's a much deeper level of blending.
Exactly. And the other big piece is physical interaction.
You mentioned this with the Pokémon earlier, not walking through rocks.
Right. In basic AR, that virtual Pokémon might just clip right through your real coffee table. In MR, the system understands the table is there. The virtual character would realistically stop, walk around it, maybe even bounce off a real wall if it ran into one.
So the virtual elements are aware of and constrained by the physical environment.
That's the goal.
Yeah.
That level of interaction makes the blend between digital and physical much, much more convincing. That's the promise of spatial computing fully realized.
Okay, that clarifies MR. Now let's zoom out again to the metaverse. We defined it, but the vision goes way beyond just, playing games.
Oh, absolutely. The vision is vast. Think of it as a 3D internet, a persistent universe where you can do almost anything you do in the real world and more. Socializing, working, shopping, learning, creating.
So what specific technologies are the pillars holding up this grand metaverse vision?
Well, VR and AR are the obvious entry points, the windows into it.
Yeah.
But other tech is just as crucial. Blockchain and digital assets. This is key for making virtual ownership real. NFTs, virtual land, avatar skins. Blockchain provides a way to prove ownership and trade these things securely. Your virtual stuff is actually yours.
Okay, so digital property rights. What else?
AI and content generation are massive. Creating these vast, detailed worlds takes enormous effort. AI can help automate the creation of scenes, characters, even dialogue for NPCs, non-player characters using large language models.
Makes building the metaverse scalable.
Exactly. Then you have virtual avatars and social interaction, customizing your digital self and having your expressions and gestures mirrored in real time for natural communication. That's vital for the social aspect.
Feeling like you're really talking to someone.
Right. And finally, digital twin and spatial simulation. This involves creating virtual replicas of real-world things, factories, cities, even the human body for analysis, training, or remote control.
Okay, so those are the building blocks. Where are we actually seeing the metaverse applied today?
It's already happening in diverse areas. Entertainment and gaming is the obvious one. Roblox lets users build entire worlds. Fortnite hosts massive virtual concerts.
Millions of people attending.
Yeah, it's a genuine cultural shift. Then there's remote learning in office. Meta has platforms like immersive learning and Horizon Workrooms, trying to make remote collaboration feel more real, sometimes using AI assistants.
Commerce, too. You mentioned Nike Land.
Right, commerce and retail. Nike Land on Roblox lets you try on virtual sneakers, buy NFT gear. It blurs the lines between online shopping and experience.
And virtual real estate. People are buying virtual land.
They are, on platforms like Decentraland and The Sandbox. Plus, real estate developers use VR for space display, giving virtual tours of unbuilt apartments. Saves building physical models.
That makes sense. And finally, healthcare.
Yeah, this is really impactful. XR Health offers virtual rehab programs patients can do at home. Trip uses VR for mental wellness, meditation, even PTSD therapy. It's showing real therapeutic potential.
So it's really branching out far beyond entertainment.
Definitely. It's starting to weave into many different fabrics of life.
Let's ground this further with some specific case studies of spatial computing in action. You mentioned Metaverse Seoul, a government-run metaverse.
Yeah, the world's first, launched by Seoul's city government. It's a virtual platform for public services.
How does that work? Like you visit a virtual city hall?
Pretty much. You can take virtual tours of the city hall, historical sites using VRR. They use blockchain for secure identity and transactions, maybe even online voting.
Wow.
They use digital twin tech for urban planning simulations, testing traffic flows, things like that. And it relies heavily on 5G and AI to handle potentially hundreds of thousands of users smoothly and offer personalized services.
What kind of services? Filing taxes?
Getting tax info, yes. Accessing administrative documents, ebooks from the city library, even getting virtual consultations. The aim is convenience and accessibility.
Sounds impressive, but risky too, for a government.
Definitely risks. Our sources flag data security as a major concern. The digital divide, making sure everyone can access it, getting citizens to actually use it, and the ongoing legal and technical upkeep is substantial.
Okay, interesting experiment. What about the Infinite, the VR space experience?
This one's really cool. Created by a Canadian team with NASA. It uses actual 360-degree footage shot on the International Space Station.
So you feel like you're really there.
That's the goal. You wear a wireless VR headset, you can walk around a large space. You experience a rocket launch simulation, float in zero-G on a virtual spacewalk, look down on Earth.
How do they make that spacewalk feel real?
It's a combination. The core is that panoramic stereoscopic footage from the ISS. Then they layer on 3D spatial audio that changes as you move. And sensor positioning tracks you, triggering interactive elements or explanations as you float around. It's a powerful illusion.
Amazing. Now let's shift specifically to immersive tech and smart healthcare. You mentioned a couple earlier, but let's dive deeper. Snow World, the pain management game.
Right, developed at the University of Washington. It's for patients undergoing painful procedures, like burn victims during wound care. They put on VR and enter this cool, icy world, throwing snowballs at snowmen and penguins.
And that distracts from the pain.
Significantly. Studies showed it can reduce perceived pain by up to 50%. It's a powerful example of using VR for non-drug pain relief. The main challenges are the cost of the VR setups and making the experience engaging and personalized for different patients.
Fascinating. Then there's Vein Viewer. That sounds more practical, maybe?
Very practical. It's an AR system. It uses harmless near-infrared light to detect veins into the skin and then projects a real-time map of those veins directly onto the skin surface.
So the nurse or phlebotomist can see exactly where to insert the needle.
Exactly. It boosts first-stick success rates dramatically. Our sources cited around 39% improvement, which means less pain and anxiety for the patient, especially kids.
Are there limitations?
Yeah, it can struggle a bit with different skin tones, and it doesn't guide the needle's path, just shows the target. Though some sources mentioned robotic injection systems as the next step beyond this.
Okay. And the Seoul University Hospital Metaverse platform, another Metaverse example, but for doctors.
Yes, specifically for medical education, it's a 3D virtual hospital environment.
So med students can practice surgery virtually.
Exactly. Remote teaching, complex surgery simulations, even international collaboration between doctors and VR. It overcomes geographical barriers for learning, which is huge for reaching underserved areas. But again, high cost to set up and regulatory hurdles for accrediting virtual training are challenges.
And finally, Philips Azurion. This sounds high-tech. Image-guided surgery.
Very high tech. It's a spatial computing platform used during surgery, cardiovascular neuro-oncology. It integrates live imaging from scanners with preoperative scans to create real-time 3D visualizations of the patient's anatomy.
So the surgeon can see through the patient while operating.
In a sense, yes. They interact with these 3D visuals using touch, voice gestures. It guides their instruments with incredible precision, aiming to reduce risk and improve outcomes in complex procedures. But it's very complex, very expensive tech, mainly found in top specialized hospitals.
Okay, one last case study, and this one's different. TeamLab Future Park. Interactive art without headsets.
Right. This Japanese art collective creates these amazing immersive environments using projection mapping, motion sensors, and real-time generative art. No goggles needed.
So how does it work? The art changes as you move.
Precisely. Your movements, your interactions, they become part of the artwork. Flowers might bloom where you stand, or digital waterfalls might part as you walk through them. It creates visual, auditory, sometimes even tactile sensations.
What's the tech behind that magic?
Lots of sensors, motion, touch, high-res projectors, often mapping onto complex surfaces, synchronized sound and light systems, and sophisticated AI and computer vision algorithms that allow the art to respond instantly and intelligently to the audience.
So it feels really participatory, personalized.
Totally. Multi-sensory, real-time, you're co-creating the experience. But it's important to note, it's usually projecting onto 2D surfaces, like walls and floors. It doesn't typically involve the kind of 3D object interaction with physics and lighting you get in true MR. It's immersive art, a different flavor of immersion.
Got it. So pulling all these examples together, what's the bigger picture? What's the overall impact on industries?
Well, these immersive experiences are clearly driving product innovation across the board. They're also offering real cost savings. In some areas, think virtual storefronts versus physical rent, or virtual prototyping versus building physical models.
And training.
Huge impact on internal training. Realistic simulations for dangerous jobs, complex procedures. It's safer and often more effective.
But it's not all easy, right? There are still major challenges.
Absolutely. The technological barrier is still high for developing sophisticated experiences. There's constant pressure to innovate and maintain content to keep users coming back. And the initial investment, the cost of headsets, powerful computers, platform development, that remains a significant hurdle for many.
So looking ahead, what's on the horizon? Where is immersive tech heading?
I think we'll see continued popularization. Costs will likely come down, making headsets and platforms more accessible, moving beyond niche markets towards the mainstream.
What about making it more immersive, beyond sight and sound?
That's the exciting frontier, sensory expansion. Imagine adding smell and taste. Our sources mentioned the idea of virtually smelling different perfumes online before you buy.
Wow, that would change e-commerce.
Or virtual travel, where you can smell the sea air. Or educational experiences where you can, smell ancient Rome. And of course, continued improvements in resolution and comfort, making displays sharper, headsets lighter, reducing motion sickness. That's crucial for long-term adoption, making it feel seamless.
Okay, we've covered a ton. The history, the tech like VR, AR, MR, the metaverse vision, real-world applications, challenges, the future. But there's one more piece our sources touched on, kind of the engine running underneath all this. Data.
Yeah, the unseen engine. For these complex virtual worlds and platforms to actually work well and evolve, you need to understand how people are using them. What works, what doesn't, what do people like? That all comes down to data analysis.
And our sources mentioned a specific tool for this, Orange.
Right. Orange was highlighted as a really interesting tool because it's a visual data mining framework. Makes complex analysis more accessible even if you're not a hardcore programmer.
So instead of digging into the tool's features, what's the big idea here? How does something like Orange help the companies building these immersive worlds?
It's about finding the hidden patterns in user behavior without needing a PhD in statistics.
Yeah.
Imagine a company running a metaverse platform. Orange can help them visualize, say, what activities users spend the most time on,
Okay.
or discover non-obvious connections. Like maybe people who buy virtual clothing item X are also highly likely to attend virtual concerts. That's the classic beer and diapers kind of insight, finding unexpected associations in the data.
Ah, the famous data mining story. So Orange helps find those connections in virtual worlds.
Exactly. It can run things like association rule mining to find those, if you do A, you're likely to do B patterns. It can cluster users into groups based on their behavior, maybe identifying socializers versus explorers versus creators.
And what does the company do with that info?
They use it to make smarter decisions, tailor content to different user groups, optimize the layout of virtual spaces, predict which new features might be popular, understand why people might be leaving the platform. It provides actionable insights to improve the user experience and grow the ecosystem intelligently. It's how they refine these worlds based on actual human interaction.
Makes sense. It's the feedback loop.
Precisely. Essential for building something people actually want to spend time in.
Okay, let's wrap this up. It feels like immersive technologies are really moving beyond just games and entertainment.
Definitely. They're weaving themselves into education, healthcare, work, commerce, truly starting to blur those lines between our digital and physical lives.
It's still an evolving field, clearly. Lots of challenges. The Vision Pro story shows that success isn't guaranteed, even with amazing tech.
Absolutely. And the focus really needs to stay human-centered. It's about understanding user needs, enhancing our lives, creating genuine connection or utility, not just pushing technology for its own sake.
So, a final thought for our listeners. As these technologies keep evolving, keep blending our realities, what new, maybe unexpected human connections or experiences do you hope they might unlock next? Something to ponder.